about experiments versus observational studies. Could you pass one back, please?
You're lucky you noticed.
So, in observational studies, researchers don't assign choices, they simply observe them. This type of study can be further divided into two categories. In retrospective studies, researchers first identify subjects in a particular group or with a particular characteristic and then collect data on a different characteristic. So, take for example, you might look back at people who died before they reached the age of 60 and look at the cause of death. Right? So, you have a group, you look back in time and gather information about something about them. That's a retrospective study. You're looking back at something. Or you could look at people who are alive currently who have high blood pressure and then also look at their blood sugar level. See if those two are related to one another or not. Okay? In prospective studies, subjects are identified in advance and data is collected as events unfold. So you pick a group of people. Let's go back to the blood pressure one. You pick a group of people who have high blood pressure, and then you look at, what is their life expectancy starting from now. Okay, so that's going forward in time. One is anytime you're going backwards, that's retrospective. Anytime you're going forward, that is prospective. You hear this stuff get reported all the time. A new study suggests blah, 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 right? You've probably read or seen something like that. The thing about it is people get really worked up about observational studies, and you can't use them to prove that there's a causal relationship of any kind. Okay? They'll do things like a new study suggests that people who drink 2 or more glasses of wine a day are frequently drunk. No,
Not true.
But they'll say things like that, and people take it as if they've proved a causal link, and they start going, oh, I should do this, and this is part of why people get confused about. They'll see, well, one study said this and one study said that, and I'm like, yeah, the studies didn't prove that there was any causal link, and so that they found different things different times. Yeah, there may be no link at all. So, is there value in doing a study then? Is frequently what students will ask, and I'm like, yeah. If you find that there's this, overwhelming, man, everybody that had high blood pressure died before they were 65, which isn't true, but let's say that was true, then it's like, okay, now maybe we need to do something more than that. Okay? It doesn't prove that there's a causal relationship, but it does give you an idea of we should study this. And frequently in reporting, they'll oftentimes say, researchers say more study is needed. Anytime you hear that, go, great, this is a possibility, but it's certainly not proven yet. Okay? On the other hand, an experiment requires a random assignment of subjects to treatments. An experimenter must first identify one explanatory variable called a factor to manipulate, and at least one response variable to measure. So you look at the explanatory variable. These people all exercised half an hour a day. We're going to assign people to do that. We're going to assign other people to sit on the couch all the time. And we're going to see what happens to their blood sugar level. Okay? That's an experiment. Humans who are experimented on are called subjects or participants. These days, they're more likely to call them participants because it makes them feel like they're doing something good. Okay? While other individuals are called experimental units.
I would not like to be called an experiment.
So lab rats.
Yeah. The specific values the experimenter chooses for the factor are called the levels of the factor. So in an experiment, you may say, this group got 100 milligrams of this experimental drug. This one only got 25 milligrams of this experimental drug. Is there a difference in the outcome? The specific values that the experimenter chooses for the factor, the combination of specific levels from all factors an experimental unit receives are called its, I think that's treatment. I'm trying to do this totally without my notes. I probably shouldn't.
Whoa, okay.
There's a lot of blanks on this.
I believe in you, Mr. Davis.
Yeah.
That was not comforting.
You know how it is. You can fool some people some of the time.
Wow.
Yeah, you
Called
could.
you a fool, sugar.
You could fool me. No, I'm not offended.
Hey, I was right.
Hey, I believed in you the whole time.
So,
This will not reach your quiz score.
the 4 principles of experimental design. Students tend to kind of gloss over this, but this is super important. Okay? First of all, control. We control sources of variation other than the factors we are testing by making conditions as similar as possible for all treatment groups. So you don't want something else that's a factor beyond your control. You'd like to try and eliminate those as much as possible. Randomization allows us to equalize the effects of unknown or uncontrollable sources of variation. Treatments must be assigned to experimental units randomly. You can't have, we volunteered to take this and this other group, volunteers to do something else. In our exercise one, you can't take, these people all volunteered to exercise and these people all volunteered to be couch potatoes, right? You're likely to have more fit people volunteering to exercises, and people who are already couch potatoes, continue to sit on the couch. Okay? It has to be random. One thing that we don't talk about very much when we're looking at it, when we set up our experiment, is replication. But you have to apply the treatments to a sufficient number of experimental units, and the entire experiment must be repeated on a different set of experimental units. So almost always when we set them up, we only do the experiment once. But you want enough units, experimental units, to where it's worthwhile. Okay? And if you really want something to be accepted by the scientific community, you need to be able to repeat it. You've talked about this in science class, right? That it's got to be repeatable. If it's not repeatable, it's a one-time phenomena, that's no good. And then the last one is something you probably didn't talk about in science. It's called blocking. So when there are attributes of experimental units that we're not studying and we can't control that may affect the outcome, we can group these individuals together and then randomize within each block. So for example, if you believe that perhaps men and women respond differently to a particular medication, you might want to block your subjects by that. Or if you are testing, let's say, a blood pressure medication, I don't keep coming back to that one, but let's say we're doing that. So maybe what you want to do is block people by how high their systolic blood pressure number is. So people with over 150, people between 130 and 150, and look at each of the groups to see how they respond to the medication. It may be that if you have really high blood pressure, this medication doesn't work as well. It lowers some people's blood pressure, but not the ones that are really high. Well, that's not what we want then, right? Or it could be the other way around. It only works on people who have really high blood pressure. Okay, it's like in the commercials where they're like, I lost 35 pounds in the first 2 weeks. And I'm like, you weigh 500 pounds. That is very little in terms of the percentage of how much weight you lost, right? But what gets reported is how much. I'm like, okay, whatever. Yes?
So they could have various attributes that affect the experiment, and then we put them all in one group together. And I'm confused, like, why do we group them together and randomize within each of the blocks? Or would we put...
So in the blood pressure one, let's say that I'm concerned that this medication affects people who have extremely high blood pressure differently than people who have more moderate blood pressure. So I'm going to divide them, let's say I divide them into 3 groups: people with low blood pressure, people with moderately high blood pressure, and people with very high blood pressure. And then within each of those 3 groups, we're going to do the experiment, and we are going to randomize which people get which treatment from the high blood pressure group, the moderate blood pressure group, and the lower blood pressure group. Right? Because it may be that those different groups respond differently. Does that make sense? So we're dividing them into groups that are the same on some characteristic.
Yeah, that blocking it out. Okay, I got you.
Okay? It's a little bit like stratifying.
Yeah. Would that be considered, like, if you didn't, that wouldn't be considered manipulating the data just because?
No, because we actually report what happened in each group.
That makes sense.
Okay? So if the differences that we observe in an experiment are bigger than what we could get from randomization alone, we say that the differences are statistically significant. So an outcome is statistically significant. And this is a phrase you might even want to consider memorizing, because occasionally someone will ask, what does it mean? Well, it's statistically significant if the probability of it happening by chance is so low that we are convinced that there must be some other explanation. Okay?
Oh my goodness. They're gonna get me
Oh yeah, those extra couple of inches are going to keep those germs away from you.
You never know, Mr. Davis. There is a world.
There is a word.
All right, a baseline measurement of what happens when the value of the factor applied in the treatment is 0 is called the control treatment. And the experimental units to which it is applied is called a control group. So the experimental units in the control group don't get any treatment. Now, we'll talk in a moment about in medicine how you do that so that they don't know that they're not getting the treatment. Okay? But they don't get any treatment. So you see, if we go back to the exercise one, we have a group that you're like, don't do any additional exercise. Do whatever you've been doing. That's your control group, so that you can see, did something change with them? The hope is that things don't change with them and that you do have a change in your non-control group or groups. So there are two main classes of individuals who affect the outcome of the experiment. Those who could influence the results, that is, the subjects, the treatment administrators, or the technicians, and those who evaluate the results. Now, in some case, the evaluation is not, it's a hard and fast number. There aren't really people who affect those. But sometimes you have people who judge, oh, this person had a wound, and I'm going to evaluate how much it's healed on a scale from 1 to 10. Okay, or if you're doing a psychological experiment, sometimes those are subject to what the person thinks, right? I've observed less aggression from this person, and they quantify that with some number. So, not allowing these individuals to know which treatment is being applied to which group is called blinding. Oh, y'all talked about blinding in experiments?
Single blind and double blind?
Yep.
Yes.
When one of the two groups is blinded, an experiment is said to be single blind. When everyone in both classes is blinded, we call the experiment double blind. So a fake treatment that looks just like the treatments being tested is called, do you guys know this one? Placebo.
Where does that word come from? Do you know, Mr. Davis?
I don't think I do.
Just was wondering.
Yeah, I don't know the origin of that. I'll look it up while you're taking the quiz later.
Feels ominous.
So this is for your control group. The control group gets the placebo. So the tendency of many human subjects especially, but occasionally it happens in other experimental units, to show a response even when their treatment is a placebo is called the placebo effect. Now, the interesting thing about this is I saw a report where there was an experiment that was done. This one particular woman that they were looking at primarily was in the control group. I've forgotten what the treatment was for. I want to say it was like for Parkinson's, for hand tremors or something. Okay? And she found that her hand tremors got better with treatment, but she wasn't getting any actual medication. The interesting thing about it is she continued to take that medication and do all the stuff that she had been doing during the experiment, and her hand tremors were demonstrably better, even when she knew that there was no medication in there. Now, you may be going, how is that possible? Well, if you know that it's fake medicine, now when you don't know, that is pretty easy to understand, right? You think you're getting medication and your body actually responds that way. But when you know that it's fake, why is it that some people still continue to get improvement? Here's the deal on that. The study that they did said the actual act of, I'm going to the doctor, somebody is checking on me, somebody is doing all this stuff, I'm having interaction about this, can in some cases help people. So they've even done some studies with terminal cancer patients where you don't just kick them to the curb and go, yeah, go someplace else and die, where you actually are checking on them and you're doing all these things. Sometimes that is helpful. Now, very often, no, but sometimes. So the best experiments are usually randomized, and I'm going to put underneath this, for randomized, they better always be randomized. Every experiment, if it's not randomized, it sucks as an experiment. Double blind if you can make it. Now, some of them it's not possible to double blind. It depends on the situation. But if you can make it double blind, that's better. Comparative, meaning you have a control group. If you don't have a control group, it's like, okay, they all got better. Would they have gotten better on their own? Maybe. This is true for a lot of medicines like common cold medicines, right? The common cold, typically people just get better on their own. The question is, does the medication actually help you get better faster? Okay? So, but you have to have a control group to compare. Otherwise, you're like, yes, they have a minor illness and they all recovered taking this medicine. And you're like, great, that's super helpful. And also placebo controlled. So comparative is possible, you're just giving them different levels. I gave them 1,000 milligrams of vitamin C as opposed to 500 milligrams of vitamin C. So when groups of experimental units are similar, it's often a good idea to gather them together in blocks and then randomize within the blocks. This is what we were talking about a little bit earlier. This is called randomized block design.
There, are you done writing? Mr. Davis, check your paper. Check your paper, Mr. Davis. Talking about me not writing when she's got 2 seconds.
So there's lots of reasons why you might want to block. Again, if you have any reason to suspect that different groups will react differently, you should block them. All right. Then matching subjects is something else that's sometimes helpful. Matching subjects who have similar characteristics that are not under study can reduce variation in much the same way as blocking. For example, and they talk about a study of this in your reading. It says a retrospective study of music education and grades might match each student who studies an instrument together with another student of the same sex and similar family income that didn't study an instrument. Right? That way, those other factors that may contribute to the outcome, well, those factors were the same for these two people. Right? So it could be that you take all of your subjects and you match them, and then you randomly decide which one is going to have the treatment applied and which one is not. Okay, I usually think of it as medicine, but it could be any kind of a treatment. Okay, in this case, the treatment is, playing an instrument. So here are two things that get confused a lot. So when the levels of one factor are associated with the levels of another factor, we say that those two factors are confounded. A confounding variable is associated in a non-causal way with a factor and affects the response. Blinding is one way to help prevent confounding. And then, as opposed to a lurking variable, a lurking variable is usually thought of as a variable associated with both x and y, that it makes it appear that x is causing y. Okay. For example, if you look worldwide at the number of TVs in a house, and you look at the general health of the people who live in the house, well, generally speaking, the more TVs, the healthier the people are. So clearly, TVs cause better health.
You need to go out and buy several TVs now.
Gonna fill a wall with TVs in my house.
Walk in the TV room when you're feeling sick.
So, what's the lurking variable in that particular case? Income. Right? People who have more money are more likely to have better access to quality health care.
And better TVs, or more TVs.
Yes.
All the TVs.
As many TVs as they want.
1 trillion.
Yeah, I'm old enough to remember when pretty much no one had more than one TV in a house.
Don't say that.
It's true.
Don't say that.
Now more
Don't
and
say
more
that.
people are getting rid of their TV.
Heck, I mean, I'm old enough to remember when people only had one screen of any kind in their house.
Was it a TV?
Yeah, that was pretty much the only kind in those days. But, I'm also old enough to remember having to get up off the couch to change the channel or,
No remote.
yeah.
That's better than having to log out and log in to all these different streaming services.
What are you saying?
No,
It definitely is.
No, it's not.
Yes, because when you have 5 channels and
I'd
you just
rather
watch
have
whatever's on the
on-demand
5,
TV
that's much
whenever I
better than
want.
having like 7 billion shows you
Instead
choose
of waiting
from.
4
Yeah, but the
hours
problem
for
with the
it to show
7
up.
billion shows is you can get sucked into just, looking for something to watch.
Yeah, the infinite
For like,
scroll.
okay, well, that hour is gone.
Jackson wishes
Yeah.
for simpler times.
In terms of TV, yes, because I just don't like having to
You're an
watch
oddball.
everything
He
on
yearns
a
to be
streaming
born in
service.
1950s.
I yearn to waste an hour finding a channel.
Oh, I
Or
just
like,
can't make up my mind.
You log in, put in a password, the 2-factor authentication, then you finally log
Do
in.
you have to do that?
Yeah,
for
then
your
you're
log
logged in,
log
and
out
then
after
you're
every
logged in,
session?
you don't have to log
Oh,
in.
I want to switch to the other
He
game.
logs
it's
out of
also
Netflix
on.
after
You
every
have to
show he
log all the
watches.
way out
At the
and
end
log
of the
into
day,
the
at
other
the end of the
one.
Why do
day,
you
he
have to
signs
log